So this is any time you want to solve a system of equations graphically on the delta math. What you have to do, for example, when we have y equals negative 2x minus 1, which is actually this line that we graphed over here, number 1. We said its slope is negative 2 over 1, and its y-intercept was negative 1. The b is negative 1. So we started at negative 1 on the y, and then we went, the slope is negative 2 over 1. So from that point, we went down 2 and 1 to the right, because that's what slope means, rise over run. Notice what you do on the delta math is you first click on the negative 1 on the y-axis, and then from there you go down 2 over 1 and click on your next point, and it'll draw the line for you. The same thing it'll do for the second line, which has a slope of 1/3 and a y-intercept of 6. So again, first go to the 6 on the y-axis and click on it. And then you use the slope 1/3, which means go up 1, 3 to the right and click on there. And you'll get your second point. And then you'll see that they meet at the point negative 3, 5. Okay, as you notice, is solving systems of equations graphically involves a lot of work. But I'd like to give you now one to try where you're solving a system of equations not using the graph, but using one of the algebraic methods that we talked about, which was substitution and addition. Those are the two methods I gave you. I'm going to erase this one now, and I'm going to give you a problem to try. Here's the problem. Our first equation is y equals 4x plus 12. And our second equation is 2x plus 3y equals negative 6. And I'm going to give you, it tells this is question number 2 on the practice sheet that if you wanted to, you could print out and have in front of you, because I use it a lot. Be going through quite a few of these problems here. It asks you to solve the system by substitution, which is the method I would probably use. But if you have a question, if you want to do it a different method, you can do it by the addition method, and you could see if you get the same answer. I'm going to give you a few minutes to try it out, and I will then show you how it could actually be done using either of the methods. Okay, so here, take some time to solve this. If you get the answer, and again, you don't have to draw the graph, you just have to give me the answer. Just give me the answer. This is not asked for a graphical solution. It's one of the methods that we were talking about yesterday. Yeah. Okay, Oriana came up with an answer. Let's see if it's the correct one. And so did a few people came up with the answer -30. Let's see if that's the correct answer. So, and I'm going to give you 3 people extra credit when I finish reviewing this. When I look at this question, I see it as a perfect setup for the substitution method because it says explicitly in that first equation y equals. It's telling me what y is in terms of x. So I can call y y, or I can call it 4x plus 12 because that's what equal means. So when I go to the second equation where I see the y, I can replace it with the 4x plus 12. That's why it's called substitution. So the equation then becomes 2x plus 3. Here's my second equation. In place of the y, I'm putting the 4x plus 12. And that's equal to -6. And when I go through this I have a regular equation with just x's, no y's in it, so I can just solve this equation by first removing the parentheses by distributing. So it'll do 3 times 4x is 12x, and 3 times 12 is 36. And I then combine the like terms, which are the 2x and the 12x, which gives us 14x plus 36 equals -6. And I'll bring the 36 to the other side to get the x's alone. So I'll have 14x equals, well, -6 plus -36. These are both negatives, so that gives me a -42. And I can even use my calculator if I want to do this. I said divide by 14, and -42 divided by 14 is -3. So the correct answer for x is -3. I'll then go back to equation 1 to find the y by replacing the x by what I now know it's equal to, which is -3. So I get 4 times, here's my x, -3 plus 12, which gives me -12 plus 12, which indeed gives me 0. So the final answer is -3, 0. And all people who sent me chats had gotten it correct. Perfect. They had 1, 2, 3. Okay, just want to see so I can give the extra credits. Naya, Tahira, and Ariana. Great. Okay. Let me give you another problem. One that's coming right off of the previous exam. I think, I don't know if it was a midterm or a final, but here's a question that came from one of Medgar Evers' final exams or midterms. I'm going to try to this example. And since it's one of the examples on one of these tests, it's going to be a multiple choice question. So here's the question. It says solve the system of equations using any method. Here's the system of equations. 4x minus 3y equals 19 is my first equation. And 5x plus 4y equals -15 is my second equation. And here are the choices that they're giving me as answers. 1, -5. Choice 1. 1, 5 is our second choice. -5, 1 is our third choice. And our fourth choice is -1, -5. And they want you to, so this is a multiple choice question. They want you to solve the system of equations and then pick the right answer. Okay, so I'm going to give you about 5 minutes to try this one. And this, as I said, it came right off the final. That might have been a midterm. Sure. Okay, I see a couple of people are coming up with choice A. Let's see. Okay, see a lot of people answered the question. Let's see. So, one. I just want to give everybody the extra credit before I do the problem. Okay, Tahira. Oriana. Yana. Kayla. Iris. Emma. Giving out a lot of extra credits here. Michaela. And I see everybody came up with this same answer A. So let's try it and make sure that's the correct answer. I tend to believe that it must be, but I'm so proud that so many people made the attempt. I'm glad you're seeing that this is something that you would face on a departmental exam. And of course, those are the most important exams, though classwork and homework and quizzes are extremely important. Most important is, of course, the midterm and the final. Okay. The way I would do it is I would like to get rid of the y's. And if I want to get rid of the y's, I'm going to multiply the top equation by the 4 and the bottom equation by the 3. And since this has a minus sign and this has a plus sign, which is what we wanted to have, one to be positive and one to be negative, we're not going to do anything with the signs. We're just going to use these positive numbers. So the first equation, when I multiply it by 4, will give me 16x. And 4 times -3 is -12y equals 4 times 19, which is 76. There. Okay, the bottom equation multiplying that by 3 will give me 15x plus 12y equals -45. And if you notice, Obviously, the method I had used was what we call the elimination or addition method, because I saw it just was set up that way, x's, y's equals numbers. So it's set up to do this elimination method. And by multiplying by the different numbers, I got the coefficient on the first equation of the y to be -12. And on the second equation, the y's coefficient is +12, which is what I always want to end up with. I want to end up with one of the variables having a positive number and the other a negative number, the same number, so that when we add them, we get 0. So when we add these two equations down, we're going to get 16x plus 15x, which is 31x. The y's, of course, have been eliminated. They've crossed out. And then we do 76 minus 45, which gives us also 31. And when I divide by 31 on both sides, I get x equals 1. Now, actually, before I do any more work, I look at the choices. Notice if there are two choices that have 1, so I have to do more work. If only one of the choices had a 1 as the first number, as the x, I would have had to pick that answer, so I wouldn't have to do any more work. It's always good to check. So let's pick, again, my first equation and replace the x with 1, because we now know the x is 1. So we get 4 times 1 minus 3y equals 19. So this is 4 minus 3y equals 19. And I'll bring this 4 to the other side, which will give me -3y equals 19 minus 4, which is 15. And that means when I divide by -3, my answer is 15 divided by -3, which is -5, which makes it absolutely correct that your first answer, 1, -5, is the correct answer. You could have just taken these answers and just substituted them into the equations and see which one works, but actually, this is the correct way to solve that. It was not a particularly easy one because the numbers were not so easy, but if you follow through, and I saw most people who did got the right answer, and I'm glad to see that. Let's do just one more of this type, and then we can go on to something a little different. See if you can solve this equation. While you're doing this, I'm going to take attendance. And this is going to be an open-ended question, not a multiple choice. So the first equation is x minus 4y equals -3. And my second equation is 2x minus 8y equals -7. So here's equation number 1, and here's equation number 2. While I'm taking attendance, please try and solve that system of equations. Okay, listen for your name so you can answer. Olivia August. Isis, I know you're here because
I'm here.
Yeah, and thank you for answering the question. Alvaro Blake. Alvaro. Louis Cayola. Louis. Oh, good morning, Alvaro. Okay, I see you're here. And is Louis here? Louis Cayola. Emma Charlton, I saw you also answer the question, so I know you're
Good
here.
morning.
Good morning. Demetrius. Demetrius Crowder. Desmond Fleming. Shania. Shania Haley. Kayla. Kayla, I know you're here because you sent me an answer. Hi. Sanjita Hossain. Oriana, I know you're here. So if you sent an answer to the question, I knew you were here.
I'm here.
Yeah, hi. Tahira, I know you're here also. Tahira, were you here on yesterday? Because I have you marked absent.
No, I wasn't here yesterday.
Oh, okay. Michaela, I know I saw you had answered a question also.
Good morning.
Good morning. Kiana, you had also answered a question. Carleaf. Jenna.
I'm
Tasha,
here.
who's that?
That's Jenna.
Hi, Jenna. Okay, thanks. Thanks, I'm glad you're here. Tatiana Sanchez. Naya, I know you're here. Kazandu. Kazandu Small. Trina Small. Trina. Jean Thomas. Okay, and thank you for showing up today because it wasn't our regular scheduled day. I know it must be hard for some people to, I know it wasn't easy for me because you have a standard schedule and then CUNY, it's not just Meg Evers, but it's the whole CUNY system goes ahead and says, well, today is not Monday, today is not Thursday, today is Monday. And we all know it's not Monday, we know it's Thursday. So thank you for coming. And thank you for being so involved today so that we can see, I see Naya sent in an answer. Let's see if anybody else comes up with an answer. I'll give you about 1 minute more. I'll give you a hint. There's a trick here. Okay, I think you are right, Tahira. Okay, let's work on this together. Okay, Emma, you also came up with that answer. Two people mentioned that, oh, and Kayla agrees. Okay, 3 people have mentioned that they think there is no solution to this problem. So let's see why that might be the case. Again, to me, it looks like it's a good setup for using the addition or elimination method, as we call it. And let's say you want to get rid of, since the other time I got rid of the y, let's get rid of the x's this time. So the first equation, I'm going to have to multiply by the 2. And the second equation, well, since there's no number in front of the x, it means its coefficient is 1. But if I multiply just the 2 and the 1, both of these numbers are going to stay positive, and I need one to be positive and one to be negative. So I'm just going to use a negative with one of them. It doesn't matter which one I use a negative. Don't use a negative with both of them, because you want one to turn out to be positive, which it already is. You don't want to change it. And the second one to be negative. So you just have to change one of them. So let's multiply our second equation by -1. So multiplying our first equation by 2, we're going to get 2x minus 8y equals -6. Remember to multiply everything. Our second equation is going to be, I'm multiplying by -1, -2x plus 8y equals +7. Okay, so now we add it. So the 2x and the -2x cancel out. And the -8y and the 8y also cancel out. So everything on this left side of the equation has canceled out. This is a 0. And on the other side, I'm getting -6 plus 7, which is 1. Now, here's that special case. That's why I said this is a trick, because we weren't left with only x's or only y's. Both the x's and the y's canceled out. And I was left with a statement that says 0 equals 1. This does not mean either of the answers equals 0 or 1. What this is telling me, well, 0 equals 1 is a false statement. 0 doesn't equal 1. 0 equals 0, 1 equals 1. They're not the same number. So it's a false statement, so there's no solution. And again, this sometimes is written like this, with that 0 with a line slash through it, means no solution. So very good, those people who came up with that. That's an excellent answer. And I think it looks like we're pretty good on solving systems of equations. So what I'd like to do now is spend a little bit of time showing you different kinds of word problems that are easily solved or more easily solved if we set up a system of equations. So what we're going to be doing, and I'm going to be looking at again, the questions are about 3 or 4 questions at the bottom of the practice sheet 3. And those questions we're going to be looking at now and seeing if we can set up a system of equations. And after we set up the system of equations, can we solve it? So I'm looking first at question number 7 on this sheet. I'm going to read it to you. It's what we call a standard number problem. It's going to be telling us information about different numbers, and they're going to want us to try and figure out the numbers from the information that we're getting. So what it's telling me, I'm first going to read it, then I'm going to put the important information on the board, and then I'm going to talk about how do we get from words, from a word problem, a verbal problem, to equations. That's the big thing. That's what the most important thing that you should come out of math is being able to apply what you learned in mathematics to real life situations. So that's what we're doing now. We're going to take some real life situations and try and write equations that apply to them so that we can come up with answers that we know once we have our equations correct, the answers have to be correct. So here's the question. One number is 5 more than 4 times the number, and their sum is 10. Find the numbers. Okay, so here we are. Let me write what I just, again, if you have the sheet, it would be helpful, but I'm not going to write it. One number is 5 more than 4 times the other. Their sum is 10. We want to find these 2 numbers. Okay. So number 1, what we see in this case is that we really have 2 unknowns. It says find the numbers, and it right away said one number is 5 more than 4 times the other. So we know we have 2 numbers. So let's give a name to what we're going to call these numbers. We're going to set up, and you don't have to actually write it down, but sometimes it helps to write down, because if you know what you're using your variable, your x for and your y for, then it'll be easier to write the equation. So let's make a plan. Let's call our numbers x and y. If you want to, you could call it first and second, and M. Just apply 2 letters to this. I usually use x and y. And let's call x the first number, and y the second number. Very important to know what you're calling your x and y. Then we can write the equations. Again, I like to write it down. If you don't write it down, at least have in your mind clear what you want your x to be, what you want your y to be. Don't just write equations until you have decided what your variables are going to be. Then start reading the question slowly. One number is 5 more than 4 times the other. That's one complete statement. That should give us one of the equations. Remember, we have 2 variables. It's going to have to be a system of equations. We're going to need 2 equations. So one number, let's call it x. is, remember, is our equal sign, 5 more than 4 times the other. So we have to remember, what does 5 more mean and what does 5 less mean? Because those are two similar statements. 5 more means you're adding 5 to your number. 5 less means you're subtracting 5. It's interesting, English is different than math. When I want to do 5 more, I want to take the number and add 5 to it. Let's say my number is x plus 5. Even though we're saying the 5 first, we're really putting it on the end. So to say 5 more than 4 times the other is we have to take our other number, which is y, multiply it by 4, because it says 4 times means multiply. That's 4y. And it's 5 more plus x equals 4y plus 5 is the algebraic interpretation of one number is 5 more than 4 times the other. Notice I added 5 at the end. Now, when it comes to plus, when you're adding, if you would have written 5 plus 4y, of course that would have been correct, because there's no difference between 4y plus 5 or 5 plus 4y. Why I like to be careful is because when we get to the word less, then you're subtracting, and in subtraction, the order of subtraction is very important. And 5 less, if the question would have been 5 less than 4 times the number, you would have had to do 4y minus 5. The 5 would have had to be subtracted at the end. So let's remember when we're doing this, if you have something more or less, that's something that's being added when it's more or subtracted when it's less at the end. Okay, here's our first equation. Now we need another equation, and that's why we have a second statement. Their sum is 10. Well, what does the word sum mean? The word sum means add the sum of the two numbers, so that means add the x plus y is going to be equal to 10. And now I have created my system of equations. And now I want you to solve this system of equations. I'll give you a couple of minutes to do that. Okay, let's see if we can work this out together. x equals 4y plus 5, and x plus y equals 10. So to me, this looks like a good setup for substitution, because in the first equation, I have x written explicitly in terms of y. I can replace or substitute for the x for y plus 5. So if I do that, I'll get 4y plus 5. I'm doing that in place of the x, plus the y that I had from before equals 10. And adding the like terms, 4y plus y gives me 5y plus 5 equals 10. And I'll subtract this 5 from both sides. So I get 5y equals 5, because 10 minus 5 is 5. And then divide by 5. And it gives me that y equals 1. So my first number, my y number, which is my second number, is equal to 1. And to find the first number, I'm going to go to this equation and do 4 times 1. X equals 4 times 1 plus 5, which gives me that x equals 4 plus 5, or 9. And now I have my two answers. My first number was 9, and my second number was 1. And that's the answer to the system of equations. So notice we used our knowledge of algebra to solve this word problem. Okay, I'd like to do one more of these type. And one of the type that very often does come up on a midterm or a final. I'm going to do one, and then I'm going to give you one to try on your own. Okay, so let's do this one. It happens to be question number 8 on the practice sheet. Listen to the question, then I'll write it down again. Tickets to a local movie were sold for $5 for adults and $3 for students. If 150 tickets were sold for a total of $610, how many adult tickets and student tickets were sold? And this is a very common type of problem where you have two types of items, and you know the price for each item individually, and you want to know, and you know how much money you made, you want to know how many of each kind you had. It could be tickets to a movie, it could be sweatshirts to a crafts show, it could be somebody going and selling tickets for a concert, and they have the different tiers tickets, A tickets and B tickets, better tickets and not such good seating tickets. Anytime you have two types of items that have different prices, you can set it up as a system of equations. So let me again write the information on the board, and let's see if we can come up with an equation. Again, as I said, this is a very common type of question to be asked. It's as an application. So we have tickets to I'm not writing the tickets part. I'm writing that the tickets to a local movie were sold for $5 for adults and $3 per ticket for a student. So we know the individual prices. A total of 150 tickets were sold. And this is a total of $610 was made from selling those 150 tickets. And we want to know how many adult tickets were sold and how many student tickets were sold. And again, we're going to have to first decide what our variables are going to be, and then write our system of equations. Again, it's talking about two different things, adult tickets and student tickets. So we have two variables. We're going to need a system of equations. Okay, so should we call adult tickets A and student tickets S just to get away from the X and the Y? So let's call this A. But what does A stand for? Not how much an adult ticket is, because we know what it is. Don't say A stands for adults. A stands for the number of adult tickets. I really want to be pretty specific as to what my variable represents. If I just say A is adults, I'm not really clear what I mean. In my head, you don't have to write it down, but in your head, you should be clear that the A is standing for the number of adult tickets, because and you'll always know what it will stand for because you look at the question. How many adult tickets and student tickets were sold? So how many means the number. That what you're looking for, that's what your variable should represent. X will then equal the number of student tickets. Okay. Now, since this is all in dollars, I'm just going to call this $5 and this $3 and this $610. In other words, we really don't need that 0.000 when we're working out the problem. It's just going to make the thing look much more complex. What do we know? Well, the first thing we know is that a total of 150 tickets were sold. Now, that has nothing to do with how much the price of the ticket was. It's just how many were sold. And since A stands for the number of adult tickets sold, and S for the student tickets to get sold, together is the total number of tickets sold. So my first equation becomes A plus S equals 150. The number of adult tickets plus the number of student tickets is 150 tickets. Notice I didn't use the 5 or the 3 because it had nothing to do. That first statement has nothing to do with how much they cost. But that only gives me one equation. So my first equation, we look at how many do we have without including the money, without including the price. Now we have to include the price. Because the second equation has to do with how much money totally was collected. So let's think. If you charge $5 for each adult tickets, then the amount of money you're going to get from the adult tickets is 5A. A is how many tickets? Let's say you sold 20 tickets and each ticket is $5. Then the amount you're getting is 5 times 20, $100. In other words, with the money involved, you have to not only take the price of the ticket, but also take in mind how many were sold. How much did they make on the student tickets? Well, each student ticket is $3. So they're making 3S for the student tickets. And together, these two are going to add up to the total amount of money that they got. So the 5A plus the 3S will just give us 610. So again, look how we set it up. First, we just took into consideration the numbers and the variables that had to do only with how many, with nothing to do with money. Then, when I had to introduce the amount of each ticket, multiply it by how many there are for each to get me the total amount of money sold, made. And notice, it's easier not to say 5.000, but just to say 5A. Now, again, we have a system of equations, so we can solve this. And again, it's set up like a standard system of equations, A's, S's equals numbers. And I'm going to use the elimination method. So let's say I want to get rid of the A's, which means I'm going to multiply my first equation with a 5. And the second equation, well, the number in front of here, there's no number, there is 1. And again, we have the situation, they're both positive, so I need to use a negative with one of them. It doesn't matter which one I use. So therefore, I'm going to get these equations. Multiplying my top equation by 5 gives me 5A plus 5S equals 5 times 150, which is 750. And the bottom equation multiplying by -1 becomes negative 5A minus 3S equals negative 610. And again, if you don't like using these, are a little bit higher numbers, you could use your calculator. 5A minus 5A cancels out. 5S minus 3S gives me 2S. And 750 minus 610 gives me 140. And then I just divide by 2. And my S equals 70. Which is telling me that the number of student tickets sold was 70. To figure out how many adult tickets were sold, I can again go to my first equation. A plus S, well, now we know S is 70, equals 150. Subtract the 70 from both sides, and I get A equals 80. So 80 adult tickets were sold and 70 student tickets were sold. Notice you have to be make sure to be careful. If one of these numbers would have come out to be a negative, I would have known that that couldn't possibly be a solution, because you can't sell a negative number of tickets. So let's see if I can give you a similar problem. Again, this is something called off an old final exam. So I'm going to do it as a multiple choice. The multiple choice. Can I erase this? Okay. No objections. So I'm going to read the question and write the pertinent information on the board. And then I'll give you time to solve this. Tickets to a local, again, it's a local movie, were $10 for general admission. Okay. And $6 for seniors. So here's the price of the tickets. There are two types of tickets. One is for regular people and one is for seniors to get a discount. The regular people pay $10 per ticket, but the seniors only pay $6. Now here's the next of the important information. 190 tickets were sold. For a total of $1,260. How many general admission tickets were sold? Now notice they're only asking about the general admission tickets, not about all the tickets. I'll give you the answers that they gave. Choice A is 40. Choice B is 150. Choice C is 30. And choice D is 160. So let's see if you could come up with an answer A, B, C, or G. Remember to pick one of these answers, A, B, C, or D. You have an answer, you can put it on the chat. Okay, anybody have an answer? Okay, I guess we want to do it together then. All right, just like we did before, we're going to have to decide what variables we're going to use. I'm going to use X and Y again because that's my standard default. But if you want, you could have called this G and this S. But I'm going to call X the number of general admission tickets, and Y the number of senior tickets. So that I keep track as to what each variable represents. The X is the general admission, how many there are, and the Y is how many senior tickets that were sold. So again, we go to our first statement that 190 tickets were sold. Again, this is the case where there's no money involved, so we just use the X and the Y. The X plus the Y has to equal 190. The total number of general admission tickets plus the senior tickets is all going to add up to 190 tickets. Okay, now we start including the price. The price or the amount of money that we get from general admission tickets is 10x, because the price of a general admission ticket is $10. So you have to multiply the 10 times the X to get how much money you're making from the general admission tickets, plus how much money you're making from the senior tickets, but each senior ticket is just $6. So you're getting 6Y for the senior tickets. And that all adds up to the total amount of money, $1,260. Don't mix up the 1,260 with the 190. The 190 has nothing to do with money, so that goes with the equation that has no money included in it. The 1,260 is amount has to do with the total amount of money, so that's where we have to include this $10 and $6. And again, what I'll do is okay, so in this case, they asked us specifically to find how many general admission tickets were sold. which means they want me to find out what's X. They're not even asking me to find both X and Y, just asking me to find X, which means it would make most sense for me to get rid of the Y because I want to be left with the X. And if I want to get rid of the Y, then I'm going to multiply the top equation by the 6, the bottom equation by the 1. And remember, one of them has to be negative because these are both positive numbers, so I'll make this my negative. So my first equation will become 6x plus 6y. Okay, now I'm going to take a calculator and multiply 6 times 190. Which gives me 1140. Multiplying the bottom equation by -1, I get negative 10x minus 6y equals negative 1260. Okay, now we add. Again, these are set up for the addition method. 6 minus x minus 10x is negative 4x. The y's we wanted to get rid of, so they cancel out. 1140 minus 1260, let me do that on my calculator as well. Gives me negative 120. And if I divide by negative 4, I get x equals negative 120 divided by negative 4 is positive 30. And remember, x is the number of general admission tickets. Be careful if you solve for y and your answer came out to be 190, that you realize that that was how many senior tickets were sold. And you wanted to know how many general admission tickets. So that's one of the things you're going to have to be careful about on a multiple choice exam, is to make sure that you're answering the question, and the correct answer was choice C. I hope some of you did get choice C as the correct answer. Okay, I'm going to let you go a little bit early today because I think we did a lot of work and I think we accomplished. And we're going to be finishing this chapter 3 tomorrow, and perhaps starting with chapter 4. Patrice, can I speak to you after class?
Yes, I'm here.
Okay, you know what? I'm going to end the session and then I'm going to come on again.
Okay.
Okay, so re-sign in the same way.
Okay, no problem.
Okay.
Thank you.
Okay, everybody, I'll see you tomorrow. Tomorrow's another session. Thank you for showing up today. Have a good day. Bye. And thanks for being so involved. It was a great class today.